Good evening and welcome back to Mr. Smith's AP Stats online notes. We've got one more set of notes here to get through, actually just a couple more slides to finish up this particular section. So let's take a look at those real quick. Still talking a little bit about some errors you might approach or you might come across in your sample surveys, even if your sampling methods are good, okay? Before we get to that, again, the inference for sampling. The purpose of a sample is to give us information about the larger population. And again, there's a definition of inference here. It's the process of drawing conclusions about a population that I've mentioned that a couple of times, and I'll continue to sort of define that word inference for you. It's kind of a new word, at least in mathematics. So this is the process of drawing conclusions about a population from a sample. Okay, so the question is, why should we rely on random sampling? Why is random sampling so much better than any other sampling method, like our convenience samples or our voluntary response samples? And the purpose of, and mentioned this before, the purpose of a random sample is to eliminate any bias. Bias from the interviewer, bias from the population, anything that might cause a systematic favoring of one particular outcome. So that's one reason. The other reason is when we randomly sample, we allow the laws of probability to take over here. And from the laws of probability, and we'll talk about those laws later in chapter 5 when we get there, they allow trustworthy inference about the population. It's those laws of probability that tell us that yes, while going back to our the football stadium for a Taco Bell deal and sampling the fans at the football game, while it's possible that we could get a sample of all Roncalli students as our sample, it's not very likely in terms of probability. In all the different possible combinations for a sample, that's going to be less likely to happen. So we allow probability to sort of take over. And so when that happens, we sort of trust that our sample will give us a good representation of the population. Now, it doesn't mean that because we do a random sample, that when we distribute our survey and get our results, that we're going to have such a clear picture of the population that there's no room for error. That's not true. Results from random samples come with a margin of error, and any decent reporting site that reports the results of a sample survey should actually give you the margin of error. We do it in political polls all the time, okay? Margin of error doesn't mean that something went wrong. It just means that there is some variability in your sampling. This comes from what's called sampling variability. And that sampling variability is what we've discussed before also. I'm not going to be able to get all this in here, so bear with me. But anyway, sampling variability. When we went to the Coke versus Pepsi, right, we go back to that activity, and you guys just randomly guessing. A third of you should guess correctly. 1 in 3 chance of getting it right if you just are going to randomly guess. But we talked about if I had you guys do the experiment over and over and over again, we won't always get exactly a third of you guys guessing correctly. It'll be all over the board, sometimes more, sometimes less. And so just in the nature of sampling, since we're only going to sample a little bit of the population, there is going to be some variability. And we account for that sampling variability, that natural variability that we just can't get rid of, with a margin of error. The margin of error sets bounds on the size of the likely error, right? I didn't look up, I meant to President Obama's approval rating. It's wherever it is. I think last time I saw it was fairly low, 30-some%, say 32%, and it always comes to the margin of error. His job approval rating is 32% with a margin of error of 3%. So it could be as high as 35%, it could be as low as 29%. That's just accounting for that natural sampling variability. Now what we also know is that the larger random samples give us better information about the population than smaller samples, and that should just make sense, right? The more we look at the population, the clearer picture we should have of the population. And so larger sample size will always be preferable to smaller sample sizes, but there's a trade-off, right? What's the trade-off to a larger sample size? Okay, larger samples are going to cost more money and take more time to carry out larger sample surveys. Okay, but larger is always better. We just got to figure out at what point do we sort of reach that law of diminishing returns, and that's a term that you'll come across in economics if you haven't yet. As far as how clear a picture we want of the population. Okay, now, oops. Get rid of that guy. Okay. Most sample surveys are affected by errors. We're going to talk about some errors that we're going to get even if our sampling method is correct. So most sample surveys are affected by errors in addition to this sampling variability. So there's natural variability. We know it's going to happen, so we can't pinpoint one proportion of yeses or nos or whatever. There's going to be a margin of error. Unless the sample survey is set up exactly correct with all circumstances accounted for, there's going to be some other errors. Good sampling technique includes the art of reducing all sources of error. Okay, so this cartoon, this Calvin and Hobbes cartoon, is a pretty good example of what could happen even if you try to sample using a random sample. Now this isn't a random sample, but and if I remember correctly, it's been a while since I've seen Calvin and Hobbes. Calvin's the boy, and I think Hobbes is the tiger. But so Calvin's in this magazine and says, "I'm filling out a reader survey for Chewing Magazine." He says, "See, they asked how much money I spend on gum each week, so I wrote $500. For my age, I put 43, and when they asked what my favorite color is, I wrote favorite flavor is, I wrote garlic/curry." Okay, and Hobbes says this magazine should have some amusing ads soon, and Calvin includes, "I love messing with data." So what is that getting us to? First of all, this is a voluntary response sample, right? So it's not even a good sampling technique. But even if you have good sampling technique, there are other issues that come up, and the cartoon talks about them. So where are all of our sources of error going to come from? Well, we have specific names for the different errors. What I want to make sure that you understand, I mentioned before about being careful about how you use statistics terminology. Use it correctly and you sound incredibly smart. Use it incorrectly and you don't so much. So when in doubt, try to sort of explain your way out of a situation. But there's really two sources of errors that we're going to encounter. One is sampling error, right? Errors that we are going to come across in our sampling method, right? We've already talked about two. That's where our convenient sample sits. And that's where our voluntary response sample of sampling sits. Those are sampling errors. Okay, those are our non-ideal ways of sampling. We've discussed those already. Undercoverage is another one of those sampling errors. What we mean by undercoverage is when we decide to sample, and it's usually in our sampling frame. It comes from our sampling frame, and there's a new terminology. There's a new word that we haven't experienced yet, and I'll try to make a note of that somewhere here. This is in the sampling frame. And your sampling frame is just the collection of individuals that you're going to sample from. Ideally, it's the ideally, it's the population, but if you're not careful, your sampling frame becomes limited. So sampling frame are the individuals from which you're choosing. And I'll leave it at that. You're choosing your sample. If you want to include choosing your sample, but I'll leave it at that. Undercoverage is an error in your sampling frame. It's when groups in the population are left out of the process of choosing the sample. For example, if I'm going to survey the student population about the football stadium and Taco Bell question, but I'm only going to conduct, since I'm on this end of the building, I am going to, I'm going to choose students from this side of the building, okay, as opposed to the freshman academy. So I can if I set my sampling frame up as the students in this side of the building, then I have kept the freshmen from being part of the sample. That's undercoverage. Freshmen are going to be undercovered, underrepresented. Using telephone books is another situation of undercoverage. You leave out the people that have unlisted numbers or don't have a landline at home, okay? Which I imagine some of you guys actually don't have landlines at home. Those are going away pretty fast. So that's an example of undercoverage, and undercoverage fits into this sampling error. Now, there are still errors that you come across after you've gotten your sample, post-sample errors, right? What we call non-sampling errors, okay? And when you're talking about errors in a sample survey, it's okay to refer to this is a sampling error, this is a non-sampling error, as opposed to, oh, this is undercoverage, or this is non-response, or whatever. You can just refer to them as sampling or non-sampling errors. And that would be sufficient. But our non-sampling errors can come from a couple of different places. One, non-response. Non-response occurs when an individual chosen for the sample can't be contacted or refuses to participate. This happens all the time, right? You randomly choose your sample, you're ready to go, and you're going to conduct a phone survey. Inevitably, when you sit down to dinner, the phone rings. Your parents probably do this all the time if you haven't done it yourself. The phone rings, you answer it, you say, hello? And there's about a 2-second pause. I'm not sure what that pause is all about, but if it's a survey, you're guaranteed to have a pause when you say hello. And when you get that pause and then say, hello, Mr. Smith, I'm doing a survey, and next thing you know, you hang up the phone, right? Click, I'm done. I don't have time for this. I'm sitting down for dinner. That's your non-response. I refuse to participate, okay? Or if they call me during the day and I'm at work, and I can't answer the phone, then there's your non-response as well, right? You've already got your sample. Your sampling method was fine. It was random, but you just couldn't contact the person that you wanted to do the survey. That's your non-response. That's an error because now my opinion is not going to be recorded. And we needed that to be a random sample, so you have to go on and choose someone else, okay? Another source of non-sampling error after you've gotten your sample set and ready to go is what's called response bias, and that's what Calvin was doing in the cartoon strip before. It's a systematic pattern of incorrect responses in a sample survey that leads to response bias. And incorrect responses for a couple of different reasons. Maybe someone likes to mess with data like Calvin does, or maybe it's just the question that you've decided to ask that just becomes hard to answer truthfully. You go to Subway up the road here at Franklin Road, on Franklin Road, and really I think any Subway does this, but your receipt will have a survey for you to take, and if you do the survey, they give you a free cookie. So I always do the survey. But anyway, one of the questions is, how many times have you eaten at a fast food restaurant in the past month? Well, fine. I understand why they want to know the answer to that, but it can be kind of tough to sit down and answer that question. And they do give you ranges, so they just want to know that whereabouts. But if you ask a question like that, how many times have you had to fill up your car in the past year, right? Or have you been to the dentist in the last year? And you answer yes, but it was actually a year and a month ago, right? Things like that. It's questions that can be difficult to actually remember the answer to. Can get you into response bias also, but very unintentionally, not someone intentionally lying to you. Okay, that's response bias. And last but not least, the wording of questions is the most important influence on the answers given to a sample survey. How you phrase the question can sometimes lead someone to give you an answer, a particular answer, right? For example, if I'm going to do the football stadium Taco Bell survey, and even if I do a random sample of the entire community, right, get away from the stadium setting, from the entire community, and I ask, since the stadium was so expensive and caused your property taxes to go up, would you support tearing down the stadium and putting in a Taco Bell? Okay? If you word the question something like that, my guess is you're going to get a lot more yeses than what you might actually otherwise have gotten had you left out the information about the stadium being expensive and raising property taxes. Okay? So you have to be careful, and that's a pretty obvious situation of wording of the question. But sometimes surveys do that. As a matter of fact, there was the survey about what to do with snow days last year put out by Central Office. And what I may do tomorrow in class is pull that survey up and let you read it and see if we can't get a real world example of how wording of the question can mess with your data. Okay? But those are your non-sampling errors. These are all things that you really can't control. I mean, non-response, response bias, and wording of the question. I guess you can control wording of the question. Sometimes writing good questions can be tough, but some of the stuff you just can't control, but you need to be aware of and try to factor out the best you can. Okay? So there's our sample surveys. That wraps us up here. There is the Check Your Understanding on page 224. And we'll let you guys work that out right now. Come up with your responses there, and then we'll take a look at some of those responses at the beginning of class tomorrow before we get you to your homework, okay? Quick summary of this particular section. Sample survey selects a sample from the population. Random sampling is what we want to do. We want to use chance to select our sample for us. A couple of different ways we can do that with a simple random sample, a stratified random sample, and a cluster sample. Some of the things that we want to make sure that we're aware of. Failure to use random sampling often results in bias. We want to make sure that when we talk about bias, we always give it a direction, a specific direction. Is it going to overestimate, underestimate a particular response? Some sources of those biases would be voluntary response samples, convenient samples. Another type of sampling error is under coverage. Under coverage may not lead to a particular bias, but it's still a sampling error. Even if you're doing a random sample, can get to some sampling error there. And then some non-sampling errors that we talked about. And again, you can always refer to errors in your survey as sampling versus non-sampling. You don't have to give it the particular name if you can't come up with it or whatever. But some of those non-sampling errors are going to be non-response. People just don't answer, or you can't get a hold of them. Response bias, people give you incorrect answers, whether it's intentional or unintentional. And then how you word your questions can lead to a particular response. Okay? So that's that. We'll talk about in the next section the difference between an observational study, which is what a sample survey is, versus an experiment. And then we'll really get into our experiments and how to design those guys out. Okay? And enjoy your night. You do have a homework assignment if you choose to work on. You may, you don't have to. We can get to that in class tomorrow. Okay?